In this task, I'm going to use some GRASS tools to allocate portions of the road network served by each San Francisco police station, which is a different kind of network analysis than we did in Task 1. The GRASS is a very mature, powerful FOSS4G software package. Unfortunately, it has a very unique data structure that can be initially intimidating to new users. The good thing is that Qgis Desktop has a GRASS plugin that provides a much more intuitive interface to this large suite of GRASS analysis tools. One thing about GRASS is that it uses its own file format. So here I have the Lab6 Task2 Qgis project open with two layers, the police stations and the San Francisco streets. These are GRASS vector maps. So in GRASS, a vector map means a GIS layer. And they're stored in a GRASS database, and a GRASS database is essentially a folder containing GRASS data. The GRASS database is the GRASS DB folder under Lab6. These datasets have been imported into GRASS from shapefiles. In Qgis Desktop, they'll behave just like any other layer. However, since they're stored as GRASS vectors, you can also use the suite of GRASS tools with them. And these tools include a set for network analysis. So first I'm going to enable the GRASS plugin. So I have data loaded into my Qgis project that is residing in a GRASS database, but I'm going to enable the GRASS plugin. So I'm going to go to the plugins, manage and install, and on the installed tab just check the GRASS plugin and click close. And this shows up as a new toolbar. So the data is already set up for us in this project, so we don't have to do anything in that regard, but I do want to introduce the GRASS data structure to you. As I said, GRASS data is stored in a GRASS database, which is, again, simply a folder. Inside that database will be folders called locations, and inside locations will be folders called map sets. So locations represent spatial extents and coordinate reference systems that you identify when you create the location. Map sets are a way to organize data, so you can tier the data by users or by categories of data use, such as hydrology or transportation. Another detail is that every location contains a default map set named permanent. So to begin working with the GRASS tools, I need to have a GRASS map set open. So to do this, I'm going to go to the GRASS toolbar and click the Open Map Set button. I'm going to choose the GRASS database as my GIS base, the Lab6 San Francisco location, and then I have three map sets. I'm going to choose My Data and click OK. My Data is an empty map set, so there aren't any data layers in it yet. This is where your outputs will go. So whatever GRASS map set you have open defines where your outputs will land. Once this map set's open, I see a couple things. I see this red box appear on my map canvas, and this is the GRASS region, which is your study extent. So any GIS operations you do will be limited to that GRASS region spatially. Also, the remainder of the buttons on the toolbar are now active that I have my GRASS map set open. Next, I'm going to go back to the GRASS toolbar and click on the GRASS Tools button. This is the interface to all the GRASS geoprocessing tools. So notice in the main title bar of the window, it displays my location and my map set that I have open. This GRASS Tools window has three tabs: the Modules tree, the Modules list, and the browser. The Modules tree allows you to access the GRASS geoprocessing tools, and they're organized hierarchically by category. The Modules list has the same tools, but they're sorted alphabetically, and there's a search box up here that you can use to find tools. The browser allows you to see what layers you have open in your map set. Again, we don't have any data in this My Data map set yet, so there's nothing to see. But this is analogous to the Qgis browser in a sense, but just for your GRASS data. So the first step in doing a network analysis in GRASS is to build the network data set. And we're going to use a tool called v.net. So I'm going to go back to the Modules tree. I'm going to expand the Vector menu, expand Spatial Analysis, expand Network Analysis, and then I'm going to click on this v.net tool. And one note on these names for the tools, the V in v.net stands for vector. So all the tools that deal with vector data are going to start with a v dot. All the tools that work with raster are going to begin with r dot, etc. Notice also that this tool opens up in its own tabs. We have now 4 tabs: the Modules tree, the Modules list, the browser, and the tab for this tool. And then this tool has 3 sub-tabs for itself. It has an Options tab where you set the inputs and outputs and arguments for that tool. When you run the tool, it'll switch to the second Output tab, and you'll see details about running the process. And then the Manual tab is documentation for the tool. So I'm going to go ahead and populate the parameters for this tool. The name of the input vector map is going to be the San Francisco streets. And notice that these layers are named by the layer name at the map set that they reside in. The name of the input vector map is going to be San Francisco Police. The operation to be performed is going to be connect still unconnected points to vector network by inserting new lines. I'm going to leave the default ID of 1 for the arc layer, ID of 2 for the node layer, and I'll enter a threshold of 300. Finally, I'll name my output SF network. And again, this will be saved to the My Data map set. Once all that is correct, I'll click the Run button. It'll switch to the Output tab as the tool runs, and hopefully you get the message successfully finished. To view the data set, I'll click the View Output button, and it gets added to my Layers panel. So in addition to this linear network, this operation produced nodes for each police station point. The View Output only added the linear network to Qgis Desktop, so I'll now add the network nodes to Qgis with the Add Grass Vector Layer button. So that's back here on this toolbar. This looks very similar to the Add Vector Data button, but it's the Add Vector Data button on the Grass toolbar. Click that. I'm going to tell it I'm working with the My Data map set. Click the drop down and click the 2 point. Remember, when I ran the v.net tool, I specified that the ID for the arc layer was 1 and the node layer was 2, so that's why these are named that way. Click OK, and it adds those nodes to the map. So let's look at the attributes for the nodes. I'll right click on it and choose Open Attributes. It has one column named Cat with values for each of the 14 police stations. Now that the network dataset is constructed, I'll identify the road territory that each police station should serve. So in the Grass Tools window, I'm going to switch back to the Modules tree. And this time I'm going to use the v.net Alloc tool, the Allocate network. It opens up in a separate tab again. So it's picked up on the inputs correctly. The network is going to be the input arc, and the network 2 will be the input nodes. The cats are going to be 1 through 14, the IDs for the police stations. So we're going to enter just 1 through 14 separated by commas. And then I'll enter the name for the output vector map, which will be police station _ allocation. And I'll click Run. Again, it switches to the Output tab, and then I'll click View Output to add the result to the map. Before I close the Grass Tools window, I'm going to switch to the Browser tab, and I'll click the Refresh button. I'll expand the My Data vector folder, and I'll see my layers. The police station allocation layer and the San Francisco network layer. I'll select this San Francisco network layer, and I'll see some metadata in the right-hand window. So this is the command line equivalent of the tool parameters I used. This can be helpful when trying to remember how you created a given layer. It's basically a history of your geoprocessing. So with that, I'll close the Grass Tools window, and I'm going to style this new layer. I'm going to double-click on it, go to the Style tab, and I'll choose a categorized renderer. I'm going to leave the column at cat, picked up on the right one. I'm going to keep the random colors color ramp and click Classify. And I'll click OK. And now I've got the street network divided into service areas for each police station. I'm going to drag the police stations to the top of the Layers panel. And finally, I'll label the police station. So I'll open up the layer properties for that layer, go to Labels. I'm going to label this layer with the facility names. I'll click the text option down here, and I'm going to make it a font size of 9, bold. I'll click the Buffer tab and give it a text buffer with a size of 2 so that I can see the text a little better on the background, and I'll click OK. So in this lab, you were exposed to basic network routing and allocation analysis. You calculated the shortest distance between 2 points via both time and distance in the first task. And then in this task, you determined which portions of the network should be allocated to each police station. There are many applications for this type of analysis, including emergency management, parcel delivery, and general navigation.